Rahim. In the name of Allah, most gracious, most merciful. Your Excellency, Dr. Ali bin Saud al-Bimani, Vice Chancellor of Sultan Qابوس University. Your Excellency, Dr. Ali Akbar Sibawi, Ambassador of the Islamic Republic of Iran in Muscat. Dear guests, dear colleagues, in pursuance of SQU aims to strengthen its collaboration ties with the world-renowned institutions and universities worldwide, we gather today to witness another step toward scientific collaboration excellence with a number of top-ranked Iranian universities. This workshop comes as a major outcome of the late visit of SQU's main administration to Iran, during which our faculty members and researchers experienced and felt the magnitude and importance of what we could achieve together. We will start with the recitation of the Holy Quran by Abdullah Saidi.
أعوذ بالله من الشيطان الرجيم ولا تجادلوا أهل الكتاب إلا بالتي هي أحسن إلا الذين ظلموا منهم وقولوا آمنا بالذي أنزل إلينا وأنزل إليكم وإلهنا وإلهكم واحد ونحن له مسلمون وكذلك أنزلنا إليك الكتاب فالذين آتيناهم الكتاب يؤمنون به ومن هؤلاء من يؤمن به وما يجحد بآياتنا إلا الكافرون وما كنت تتلو من قبله من كتاب ولا تخطه بيمينك إذا لارتاب المبطلون بل هو آيات بينات في صدور الذين أوتوا العلم وما يجحد بآياتنا إلا الظالمون وقالوا لولا أنزل عليه آيات من ربه قل إنما الآيات عند الله وإنما أنا نذير مبين أولم يكفهم أنا أنزلنا عليك الكتاب يتلى عليهم إن في ذلك لرحمة وذكرى إن في ذلك لرحمة وذكرى لقوم يؤمنون قل كفى بالله بيني وبينكم شهيدا يعلم ما في السماوات والأرض والذين آمنوا بالباطل وكفروا بالله أولئك هم الخاسرون صدق الله العظيم.
Now, I would like to invite Her Highness Dr. Muna bint Fahad Al Saeed, Assistant Vice Chancellor for International Cooperation, to give her opening speech.
بسم الله الرحمن الرحيم. Dear Excellencies, distinguished guests, respected colleagues, Assalamu alaikum wa rahmatullahi wa barakatuh. I extend a very warm welcome to you all on behalf of Sultan Qابوس University. I extend a very warm welcome as well to our guests, our neighbors from the Islamic Republic of Iran. It is not very often that we get to be a part of history. Today is a day that will go down in history as the day of extreme importance in the modern history of the nations of Oman and Iran. Today we have gathered scientists and intellectuals from the two nations in a first of its kind Oman-Iran scientific workshop with the aim of strengthening scientific and technological collaboration. The foundations of the blessed relations between the nations of Oman and Iran are based on mutual respect and trust. Recently, these relations have been strengthened further by the wise leaderships of the two nations and have brought the cooperation between the two nations to a new level. The relations between our two nations are an admiration for many around the world. In the turmoil of recent international politics, we have proved that the policy of non-interference, mutual respect with any nation can lead to trust, strong ties, and friendly relations. Dear respected audience, this would not have been possible without the hard work and perseverance of our noble and wise leaders. Dear respected guests, I would like to take some time to introduce to you our host. Sultan Qابوس University has been at the forefront of the development of science and technology in Oman. We are a young university that stands firm on its cultural and religious values. We also believe that internationalization is an essential part of higher education today. SQU is a truly global university. Our academic staff originates from nearly 50 different nationalities. Moreover, 50% of our academic staff is international. Our researchers have published scientific articles with fellow researchers from almost 120 countries around the world. We host 17,000 students, of which 1,000 are postgraduate. We have seen a significant rise in postgraduate students, and we wish to see more of Iranian students coming to study in Oman. We are always on the lookout for creating more international partners. For this reason, in February 2014, a delegation comprising of scientists from Sultan Qابوس University visited Iran for the purpose of searching for avenues of scientific and technological cooperation. We were overwhelmed with the grand reception that we received at the universities and educational institutions in Iran. We are also greatly impressed with the technological advancement in Iran and its push for self-dependence. Upon our return, we decided that we had to create a platform from where our scientists and students could collaborate and learn from each other. Hence, the idea of this workshop developed. And today, by the grace of God, we are gathered here with our respected colleagues from Iran. We see an immense potential for collaboration between our two nations, and we are able to identify niche areas like nanotechnology, enhanced oil recovery, medicine, and biotechnology. You would have noticed that our theme for this symposium is based on these topics. Very shortly, we will begin our discussions in these topics, and with the presence of our faculty, we are confident a large number of collaboration could be initiated in these fields. Sultan Qابوس University is blessed with an array of research centers and laboratories, hosting state-of-the-art research facilities, which are one of the best in the region. Our speakers today from SQU will give you more details of these facilities, but we would like you to explore the idea of working together and using these facilities for the collaborative work. We strongly believe in planting seeds of collaboration and taking a bottom-up approach. The individual researchers are the ones who can initiate and sustain any sort of collaboration. From our side, we can facilitate the framework from which our scientists can benefit. Without taking much of your time, we would now like to show you a short video of some research activity at Sultan Qابوس University, and from then on, we will begin our proceedings for the day. I again express my gratitude for your presence here, and thank you very much for your time. Assalamu alaikum wa rahmatullahi wa barakatuh.
And now we'll start our scientific workshop.
Warahmatullahi wabarakatuh. Again, I'd like to welcome you all to the beginning of the proceedings of this workshop. Before I introduce our first speaker, just so that we maintain our time and give everybody the same opportunity to speak, we are going to leave 20 minutes for your talk and then leave 10 minutes for question and answers in the end. So at about 15 minutes, I'll give you a sign saying that we have 5 minutes. Yeah. Okay, so our theme now, at the beginning, is nanotechnology, nanoscience and nanotechnology, and I have a real honor to present Professor Mahdi Ahadian from the Sharif University of Technology, Center of Nanoscience and Nanotechnology. And his presentation topic is nanofluids for enhanced oil recovery. Professor Ahadian.
Bismillah ar-Rahman ar-Rahim. I should thank for this opportunity to introduce an example of application of nanotechnology in Sharif University. I should emphasize that more than 100 faculty members work in field of nanotechnology in Sharif University, and this one is only an example which was in field of nanotechnology and also in enhanced oil recovery. So we selected to introduce in this workshop. These results are based on collaboration between Institute for Nanoscience and Nanotechnology and the Chemical Engineering and Petroleum Department, and I will explain about it more. And all characterizations are done inside the university, and so you can see about the possibilities in Sharif University. I'm not a specialist in enhanced oil recovery, so I think today two other person will explain about enhanced oil recovery, and so simply I say that crude oil is very important for our country, Iran, and I think same is for Oman. And a small fraction, I think about 20% of oil is recovered during production. So any small increase in oil production is very important, and there are different methods for enhanced oil recovery. One of them is using water, and there are different modifications and different additives. For example, polymers. Today there is a presentation about it, and also surfactants. During recent decades, different nanostructures was checked about enhanced oil recovery, but if I want to say, only one nanoparticle, one nanofluid is more checked, which is silicon oxide. It's very cheap and it is environmental friendly. And the application, the concentration of application is high, about 1%. So you can find a lot of reports in laboratory scale in using silicon oxide in enhanced oil recovery. I want to emphasize in this short time about that nanotechnology is not only application of nanostructures. For example, produce of nanofluid based on silicon oxide and then application. It's a little more. And understanding the phenomenon in nanoscale is very important and is critical. And you can see that after a lot of works, now there is a new approach that, for example, in these two reports, we can see details that low concentration of nanoparticles is applicable by surface modification. And if we can reduce the concentration, for example, 100, the price of additive is very lower, and also we have small problems in plugging. Also, if we have the approach from nanoscience, we have a lot of experience in using titanium oxide nanoparticles in surface modification, and so I think that this one is a better choice than silicon oxide, and also titanium oxide is nowadays very cheap, and it is also environment friendly. So I think this example shows that if we have an approach, when we understand the phenomena, we can find better results, and I think now we are in the start of this application, and there is a lot of room for increasing the possibilities using this approach. We produce titanium oxide nanoparticles inside the university for another purpose, for solar cell applications. I will mention shortly at the end of the speak about it, and you can see it is not spherical, and we produce it using chemical routines, and now we sell it for solar cell application. We use the same one because we know that it is a good choice for surface application. And first we check different methods for characterization of first our nanostructures, then we prepare the nanofluid without any surfactants. You know, in flooding condition, the temperature, the pressure is high, and surfactants maybe we have problems. So nanoparticles are more stable. We do different experiments inside the university. For example, SACS is better because we can understand the stability of our nanofluid when it is in the brine and in the water. And after that, we check the stability of it, and we change some parameters in production of nanoparticles using optical methods, also zeta potential, and also TJ and thermal properties. We checked, and we were sure that this nanofluid is okay in flooding condition. Next, we use standard flooding setup inside the chemical engineering department. I'm not a very specialist in this part, but the results show that we can increase the recovery factor using nanoparticles, and there is no problem due to plugging using low concentration. You know, when we decrease the concentration, everything is better. It is more similar to brine and water, and but if we have the oil extraction, everything is okay. You see one example of recovery factor. In some cases, it was higher. It depends to our core, our crude oil, and the concentration of nanoparticles. But it is very important that we can see improvement using very low amount of nanoparticles. So I want to explain more about how we can get these results, you know, there are different mechanisms for improvement of oil recovery. For example, viscosity, which in polymer flooding is the main mechanism. Or, for example, IFT is another one, which in using surfactants is the main mechanism. Also, there is another mechanism which changes the surface of rocks, and we, based on this approach, do our experiments. If we check the viscosity, there is no change, and about IFT, there is a small change. This is the setup for IFT. We do it using the instrument produced by Dr. Ayatollahi. Now it is very commercial, and it's a good instrument for measurement of IFT. And if we measure the contact angle in this example, at the top is the rock. You see the droplet of oil, and the brine is the other part. If we add nanoparticles a short time, for example, about 1 minute, the contact angle changes. And we say that the main mechanism should be about the surface modification based on nanoparticles. So we should check about the deposition of nanoparticles. We do different experiments about the decrease in and change in contact angle, because now we are sure this is the main mechanism. And then we check about the deposition of nanoparticles. You see, this is before the flooding experiments using nanofluid. And after that, we can find titanium which is deposited onto the surface of rock. And of course, in the entrance side of the core, the amount is high, but we can see everywhere, every part in our core flooding test in laboratory scale. And a very important thing is that if we increase the concentration, you see some shapes creates onto the surface, and if we use high concentrations in the flooding, the plugging occurs and the recovery factor decrease. So it is important that using titanium dioxide, we decrease the concentration. In silicon oxide, the deposition rate is very low, and therefore it differs totally, but you have to use high concentration except surface modification of the nanoparticles. If we check about the transportation and mass balance of nanoparticles, we see that in pore volume up to 3, most of our nanoparticles are trapped inside the core plug. And if we check using ICP, the concentration of titanium inside the core plug, you see that at the entrance, the amount is high, and then it reaches to stationary states and decreases slowly. And if we use other experiments, for example, XPS is a good method for surface analysis. Of course, for this one, we use high concentration experiments. We can understand what is the how much of the surface is deposited using nanoparticles. And it is very important then. Less than one layer of nanoparticles is enough for the procedure. If we check the phenomenon, we see that using this amount, it is not possible that we achieve these results. So it seems that another mechanism is important in this condition. We should check the dynamic of extracting the oil droplets from the surface. And in this approach, this part is very important. And there is a model introduced for other situations that nanoparticles come to the wedge film, produce a wedge film where the solid oil and water are in contact, at the point that three phases are in contact. And in this condition, the concentration of nanoparticles is higher than our nanofluid, and there is a mechanism that this is important in the phenomenon. So you can have enhanced oil recovery using very low concentrations. Also, so I should emphasize that in this condition, nanoparticles come to the contact point of three phase, and then the oil is detached from the surface, and this is a new approach, a new mechanism, different from previous one, and it is totally related to nanoparticles. So we can achieve different results using nanoparticles. This disjoining pressure mechanism is a thermodynamic approach, and now we have different results that confirm that the main mechanism is this one.
5 minutes.
Okay?
You have 5 minutes.
Okay, I will finish within this time. Also, there are simulation works that indicates that the electrical charge of nanoparticles is very important, and the point that the three phases are in contact is very important, and nanoparticles come to this point and detach the particles. So the mechanism is totally, we think, different, and so there is a room for more improvement. So if I want to indicate the procedure, we produce and characterize different nanostructures, then nanofluids, and also for this approach, rock and crude oils characterization is essential. Then we should check stability of nanofluids. If we want to select another nanofluid, stability is important. Then we can different methods for checking the absorption of nanoparticles. It is very important that we have nanoparticles that absorbed on the rock surface. Also, we have a problem that we should prevent from our deposition of nanoparticles, and we have some ways to prevent it. Then we should check about the transport of nanoparticles in porous media. It should transport in long lengths to do the procedure in all places. Also, we have some methods for checking disjoining pressure in this application. We use ellipsometry methods. However, it is in, for example, a quartz sample, a little larger droplets, but it works. We can understand what occurs in our system. However, the real system is too difficult and complicated, but these steps are, I think, better for good results. And after all of these, you see that same procedure, same as other technologies in EOR is necessary, and the procedure is same. So I think that this approach is important, that we understand what occurs and then we introduce different nanofluids, and you see that results are different. So let me to mention that a few examples in our institute. For example, about solar cell, we use the same nanoparticles. You know, Iran, same as Oman. We have a good solar radiation, and we use different nanoparticles, but especially titanium dioxide to produce solar cell. And I think in Middle East we have the best group in this field. And due to the lack of time, I should mention that for water salination, we have a project using nanoparticles to produce water from seawater based on sun radiation. And also, the last example is nanostructure sensors. We have different groups in gas sensors, in chemical sensors, and biosensors. I should mention only about the gas sensor, that we can detect different gases using electrical or optical methods, and it is the possibility to sensitize the sensors for a special gas, and now it is in a commercial stage. At last, I should introduce our conference, which recently was held on Kish Island, and we have participants from Sultan Qابوس University, and you see that the Nobel Prize winner and also the Gratzel, who is the inventor of dye-sensitized solar cell, were in this conference, and I hope that in the next one we present more works about our collaboration in this conference. So the time I finish my talk, and if any question, I am here to ask. Thanks.
Thank you very much, Professor. Any questions? Yes? Dr. Salim?
There is no mic. You can hear.
The
Thank you for the presentation.
other mic.
Using nanomaterials.
Professor.
Yeah, that we are using zinc oxide nanoparticles. So I have a couple of questions. Then, if you allow me, I can say
Yeah.
we can collaborate. In fact, if I start from the end, where I do have a student who is working on zinc oxide and quantum dots for dye-sensitized cells, solar cells, and another student who is working with the plasmonic material for sensing. So we are very close. But my questions will be with the titanium dioxide, which are used for oil-enhanced recovery. Well, the first thing you have mentioned, the problem here, they stuck in the system. So what are the processes to minimize that problem? The second thing I would suggest to improve maybe your research, especially with the disjoint pressure, is to use titanium dioxide nanoparticles with nanobubbles. So the nanobubbles, what we'll do, we'll apply a pressure upwards and really minimize the contact between the solid and the fluid. So that is very, very important. The other thing where you can use...
Let me speak about what is, I think,
Okay.
better. I should emphasize that this research is, I introduced that in the first steps. So there are a lot of opportunity to work using this approach. But about nanobubbles, I think, you know, the reservoirs, the pressure is too high, and I think maybe does not work. You know, the pressure is too high in this condition, and every time we should reminder what is the condition. I'm not a specialist in oil production, and the collaboration between our group and specialists in this field is very important. You should ask from them the situation, the problems. Maybe some ideas are very good in laboratory scale, but it is impossible in field.
You see, if you take reservoir conditions, you have high pressure and high temperatures. If you take a nanobubble, stable, inside the bubble itself, if you use the Laplace equation, for example, it's a very, very high pressure. So even if you have high pressure outside, you should be able to produce nanobubbles.
You should check, but it is,
Yes.
I think, complicated. There is a technology named Afron using bubbles that are stable in that condition. But we should check everything.
Yep.
And now we are in the first steps.
The other question, are you using titanium dioxide not only for changing the surface properties of the reservoir rocks? You send them as a drive. When they come back, you get information of reservoir, and you use them as a photocatalysis at the same time.
Yes, this is an approach, but you see, I should check that. Up to 3 per volume, I should check here. I think more than 99% of our nanoparticles were trapped inside a very small length of pore. So the main reason is that we can reduce the amount when the capacity of absorption of nanoparticles is high. So in this approach, I think no nanoparticles come out of reservoirs in real condition because the length is too high. We can change. We can easily do surface modification that no particles absorbs to surface and or a less amount absorbs, and then we can